7, 9, 10, 12, 13. Hey, my work. Thank you. Oh, wait. Yep, that's it. Before we get started, questions on the homework? Before we get started, any questions on the homework? Nope. Okay. All right, guys. We're going to start the note sheet today. Note sheets for today. So, what we're starting today is solving. What we're starting today is solving these rational equations. So we're trying to find out what value of x will make these two equations be the same. We're trying to find out what value of x will make the two equations be the same. Now, one of the first things we're going to need to do, and again, it's easy to forget this because, again, well, not again, but when we start solving, it's very easy to jump straight into solving our steps that we solve and start going through that. But the first thing we should really be doing for these is our restrictions. This is the first time or first part of this chapter that restrictions, besides stating domain and range, is really going to come into play. Because the restrictions are whatever value of x that's going to make the denominator be 0. Let's put those away. Thank you. Is going to make the denominator be 0. So there's two spots where it can be 0. One of them is x plus 1, and the other is 4x plus 5. All right, guys, let's focus in here. Thank you. Now, the reason we list these here is because if x is one of these two values, if x is one of the values that makes the denominator be 0, it can't be a solution. And this is kind of nice because here, if we list these out first and get one of these two values at the end, we don't have to check it. So for x plus 1, we can subtract 1 from both sides, telling us that one of our restrictions is -1. Thus, if we solve this equation here and get an x value of -1, we automatically know it's not going to work because it's a restriction. It makes the denominator be 0. Now, the other one is going to take more than one step. We can subtract 5 first, telling us 4x is equal to -5. Divide by 4. Giving us -5/4. And that's one of our other restrictions. So if -1 and or -5/4 comes up as a solution for this here, it's a restriction. We can remove it already. Those don't work. Now for these problems here that we're starting off with, the restrictions really won't come into play, but it's good to list them out anyways, just in case they do. Questions on any of this here? So really the first thing we want to do in solving these rational equations is finding our restrictions. The next thing we want to do is find the least common denominator. We want to find out what value or what expression we need for like addition and subtraction to make them be the same. So we're going through and looking at our denominators and making sure they're factored, then finding this least common denominator. Well, x plus 1 is as simplified as it gets. 4x plus 5 is also as simplified as it gets, yes? X plus 1 has no greatest common factor, the degree is 1. 4x plus 5 has no greatest common factor, the degree is 1. So if I wanted to make these be the same or find this least common denominator, well, one part of it would be x plus 1. The other part would be 4x plus 5. Questions on how we found this expression here? Questions on anything we've done so far? So we good with everything that we've done so far? Yes? Now with adding and subtracting, when we needed this least common denominator, we would multiply the top and bottom of each expression to get them to be the same for different parts. For solving, it's a little bit different. What we're going to do is we're going to multiply everything, all of these expressions by x plus 1, x plus 1, and for x plus 5. We're going to multiply every expression in the entire equation by this least common denominator. So just the tops. So it's almost like we did with our complex fractions, our complex rational expressions, where we multiply the top by this expression and bottom. But here we're just multiplying the whole thing. Now we're going to write it out. I'm specifically going to write this out first, and then we'll do it a little bit simpler on the next one. Because when we multiply this whole expression, this not just expression, this whole equation by our x plus 1 and 4x plus 5, our first numerator becomes 3 times x plus 1 times 4x plus 5 over x plus 1. Our other numerator becomes 9 times x plus 1 times 4x plus 5 over 4x plus 5. And there's a specific reason we're doing this. A little bit. Yeah. Questions on this so far? Now it seems odd to do this step, but it's going to make everything a lot simpler. Questions on this here? All right, guys, let's focus in. Now if we look at the first, our rational expression on the left, what is in common on top and bottom? Our x plus 1 and x plus 1. Because it is multiplication on top, single expression on bottom, they would simplify out. On the right, 4x plus 5 over 4x plus 5 would simplify, leaving us with 3 times 4x plus 5 is equal to 9 times x plus 1. That's the reason we do the multiplication by the least common denominator. We multiply the entire equation by that expression to get the fractions to simplify out, to get them to simplify out completely, to where we don't have any fractions anymore. Now we can just solve. Now we just need to solve this equation here. Yes, the first thing we need to do is distribute our 3. 3 times 4x is 12x. 3 times 5 is 15. We'll do the same thing with the other side. 9 times x is 9x, and 9 times 1 is 9. Now at this point here, we need to solve for the value of x. Now since x, the biggest exponent attached to x is 1, we're just getting x by itself and everything else on the other side. So what could we do first? We can subtract 15 from both sides. So we still have 12x. 15 minus 15 is 0, is equal to 9x minus 6. Now the next thing we can do is subtract 9x from both sides. 9x minus 9x is 0, giving us negative 6 remaining on the right-hand side. 12x minus 9x is 3x. And last but not least, we would divide by 3, telling us x is equal to negative 2. Is negative 2 one of our restrictions? No. So that is the solution to this here. Questions on anything we've done so far? Now, at this point, if we wanted to, I could check this solution, say 3 over negative 2 plus 1 is equal to 9 over 4. Try rewriting that 4 a little better. 4 times negative 2 plus 5 to see if they're the same. Left side 3, negative 2 plus 1 is negative 1. Right side 4 times negative 2 would be negative 8. 3 over negative 1 is negative 3. Negative 8 plus 5 is negative 3. And 9 over negative 3 is indeed negative 3. So it does check out those are the exact same expression. Now if we were to check it, we could do this in the calculator. We could do 3 over parentheses negative 2 close parentheses plus 1. See what we got. The other side 9 over 4 parentheses negative 2 close parentheses plus 5. Enter, and it would give us the same value. Questions on this here? Just focus in, guys. Yes. Restrictions. X plus 2 and 3x plus 2 are our two restrictions. There's the ones that are going to give us values of x that do not work in our original equation if one of those two values comes up. On the test, there will be specific ones, and it will say in the instructions, check your answers. Most likely, those are the ones that are going to have restrictions. The restrictions are actually going to come into play. Here, for x plus 2, well, we would subtract 2, telling us that when x is equal to negative 2, the denominator becomes 0, so x cannot equal negative 2. Bless you. Other side, first thing we can do is subtract 2. And then we would divide by 3, telling us x cannot equal negative 2/3. So if we get negative 2 or negative 2/3, it does not work. Least common denominator. Questions on anything we've done so far? We good with everything so far, yes? Least common denominator, well, we'll need what? X plus 2 and 3x plus 2. Now that we have that, we're going to multiply everything by x plus 2 and 3x plus 2. Rewrite that 3. Okay. Questions on this so far? Now again, I said we could do this a little bit simpler, yes? So on the left-hand side of this here, we have 2 over x plus 2, and we're going to multiply by x plus 2 and 3x plus 2, yes? What do I know about the x plus 2 on top and bottom? They're going to cancel out. On the right-hand side, our 3x plus 2 and 3x plus 2 are going to, so I'll give us 10 times. Yes, and then we'll distribute. These here, it's a little bit easier to do that cancel out. Unlike 742, where we had the fractions, because in those fractions, we had top and bottom. We were multiplying that one thing by each, so it's better to multiply it out to keep track of those terms. Here, I'm able to write it out with each and every one, so when we cross it out, we're not removing it from ones that it doesn't simplify with. Does that make sense, the difference there? Now, if it is helpful to write it out as 2 times x plus 2 times 3x plus 2 over x plus 2, as we did on the last one, do that. If that helps, do that. But here we're going to distribute 2 times 3x is 6x. 2 times 2 is plus 4. We'll do the same thing on the other side. 10 times x is 10x. 10 times 2 is plus 20. Now we need to get the value of x by itself. Third time charm. Now, part of the reason we know we just need to get it by itself is the biggest exponent attached to x is 1. It's just x. We don't have an x squared. If we have an x squared x cubed term, then we get it equal to 0. Here, what can we do first? We can? We can minus 4, yes. We can minus 4 from both sides, giving us 6x is equal to 10x plus 16. 4 minus 4 is 0. 20 minus 4 is 16. Now we will subtract 10x from both sides. 10x minus 10x is 0, giving us 16. 6x minus 10x is negative 4x. And last but not least, we would divide both sides by negative 4 minus x is equal to negative 4. Is that one of our two restrictions? No. So that works. Any questions on any of this here? Are you ready for the next one? So, restrictions. Well, we have two spots, 5x being 0 and x minus 7. Well, our 5x, we can divide both sides by 5, just telling us x cannot be 0. X minus 7, we would add 7, telling us x cannot be 7. Questions on our restrictions? Now, what are we going to have to multiply everything by? Well, 5x for sure, and x minus 7. 5x and x minus 7. On the right or left-hand side, our 5x and 5x will cancel, leaving us with 3 times x minus 7 is equal to, on the right-hand side, x minus 7 and x minus 7 will cancel, leaving us with 2 times 5x. Questions on this here? Left-hand side, we can distribute the 3. 3 times x is 3x, minus 3 times 7 is 21, and 2 times 5x is 10x. Again, the degree for x is 1. So we just need to get x by itself. So the first thing we could do is subtract 3x. I would subtract the 3x because our constant term, the number without x, is already by itself. So we get x by itself. And lastly, we can divide both sides by 7, telling us x is negative 3. I know this one and the last two have all been negative solution, or the value of x has been negative, but that's more coincidental than anything else. Questions on anything we've done so far? Those will be more in 752, because I want us to get used to doing these where we're not so much focused on the restriction, but more focused on the process. But it's still helpful, especially for this one here, just to go on and state what the restrictions are, because we have x plus 3 and x minus 3 for our zeros. For our x plus 3, we would subtract 3, telling us that fx is equal to negative 3. The denominator is 0. It doesn't work. For our other one, we would add 3, which tells us that if x is equal to positive 3, the denominator would be 0. It doesn't work either. So our least common denominator would be x plus 3 and x minus 3. Because we'll need an x plus 3 and x minus 3. Because on the left side, x plus 3 and the x plus 3 we're multiplying it by will cancel, leaving us with negative 4 times x minus 3 is equal to, on the right hand side, our x minus 3 and the x minus 3 that we're multiplying it with will cancel, leaving us with 5 times x plus 3. And again, just like the previous ones, we'll distribute. Negative 4 times x is negative 4x. Negative 4 times negative 3 would be plus 12 is equal to, distribute the 5. 5 times x is 5x. 5 times 3 is plus 15. Wanting to move the 4x first, so we can add 4x to both sides. Because our negative 4x plus 4x would be 0, leaving us with just 12. 5x plus 4x is 9x plus 15. At this point here, we can minus 15 from both sides, telling us 9x is equal to negative 3. And last but not least, we would divide by 9. Now, negative 3 over 9 doesn't reduce completely, but it does reduce to negative 1/9, or negative 1/3, not 1/9. So all of our answers don't have to be integers. They can also be rational. We can also have some that are irrational, but we won't look at those today. Huh? Okay. Yeah, because our negative 4 minus 5 would give us negative 9. Okay. You're welcome. Yeah, it's very tempting because we see negative 4 plus 5, and that'll make things more confusing. Yeah. Questions on this here? Now again, I will point this out. It keeps saying in the instructions, you probably noticed this cross multiply, yes. And I have nothing against cross multiplying because really that's what we've been doing this here. The only issue I have with this, and this is coming from when I was, yes, the butterfly method, back when I was in college, and I've learned since then, this year, that there's a different butterfly method that's been taught in the middle school for adding fractions. And the less confusion we can have with that, the better. But I've also seen time and time again, or not time and time again, but with this cross multiplication, this method, that a lot of students by the time they hit college still remember multiplication and cross multiply, and that's about it. Which they see something like this, multiply, so we must be, cross multiplying only works with rational expressions that are equal. We're talking about proportions. That's really the core of it. It's a nice concept. It works well when we're talking about proportions of two rational expressions, two fractions that are equal to each other. But it kind of goes out the door when we look at this here, because we don't just have 1 and 1. So I feel like it's a little bit better to we'll do the restrictions here in a second. See what our least common denominator is, which is our 2x plus 5 and 11x plus 8. Now go on and do the restrictions here, because we would minus 5. So 2x equals negative 5. Divide by 2. X is not equal to negative. And I can get you caught back up whenever you get back. So negative 5/2 doesn't work. Next one, we're going to minus 8. Divide by 11. So x cannot equal negative 8/11. Most likely from this here, I don't think either one of those is going to come up. But yeah, if we work this out, these will cancel, giving us, well, 1 times 11x plus 8, yes? Which, nicely enough, is just 11x plus 8. On the right, 11x plus 8, 11x plus 8 cancels, giving us x times 2x plus 5. So nothing's changed from any of the ones we've done before. Now we'll distribute the x. X times 2x is 2x squared. X times 5 is 5x. Okay, now it changed a little bit. Because now we have an x squared. We have a quadratic, yes? Whenever we have a degree greater than 1, we have quadratics, cubics, quartics. I need to get this thing equal to 0. First thing I would try moving is the middle term. Because we still have 2x squared minus 6x. Part of the reason I move it first is just on the off chance the middle terms cancel. Because if the middle terms canceled out completely and we were just left with 8 equals 2x squared, square root method, get the x squared term by itself, square root both sides. Yes? So that's nice. Or we can move the x squared terms, and if the x squared terms cancel out completely, now we're back to linear as we did on the last few. It's all from there. Does that make sense? Yeah. Yes, on the off chance it simplifies here. It does not. So we'll have to subtract 8. So we get this here. Okay. Let's try, there we go, it's waking up, or opening that calculator. Now, as I've said before, and I will say it again, do not divide by a variable when you're solving. Do not divide by a variable, because what you're really doing is removing a solution. Really, that solution is x equals or y equals, whatever the variable is, equals 0, if it's in common with all the terms. However, a number, if there's a constant term across all of them, which this one has a constant factor of, get rid of it. Because it actually has a special name, and in this case, this 2 is what we call a scalar. It scaled the factor, or scaled the equation up or down. We get the same thing from a scale model, scale replica. So the scale model is just a scaled down version of the real thing. So it's just scaling it up or down. So for here, it's shrinking it down. Now for us, and I'll graph this out here, 2x squared minus 6x minus 8. What was the original graph? We have this here. Now, the one that we got when we divided by 2 was x squared minus 3x minus 4, yes? We can see that the one in red, the one that's not 2x squared, but x squared, does not go as low as the original. And it has a lot of different points, but where it crosses the x-axis, the values of x that make that equal 0 are still the same. It still crosses at those same points. That's why we can do this. Well, And interestingly enough, the two values of x that make this equation equal 0 are -1 and 4. So the solutions for this are -1 and 4. Or either one of those a restriction? No, so both of those work. Because at this point here, we got down to a quadratic. We could use any of the methods that we have to solve quadratics. Factoring, graphing, quadratic formula, completing the square root method. Any of these that work, square root method wouldn't work for this because of the 6x. But since it graphed and gave us nice numbers, graph it. That's our answer. Questions on this here? We'll finish up with this one. We do have time to do this one. Now, up to this point, it's been nice because we've had two denominators and we really just grabbed what both of them were. But we do need to be careful and make sure that they were factored. Here, our denominators are x, 4, and x. Yes? Out of those three, our restrictions, x can't be 0. Because the only two places where we can plug in a value for x is where x is just x and x. This is by itself, x cannot be 0. Now we need the least common denominator. We haven't written it out on the last few. I'll write it out on this one because we have 3 denominators, yes? One of the ones we know for sure we'll need is 4, yes? And we have x and x, yes? What would be the least common denominator between our x and our x? It's just x. And it would just be x. It's very tempting to want to say x times x or x squared. But if we look at each one, x only shows up once in each of those denominators. So we only need it once. If one of those had been x squared, then we would need x squared. So now we're going to multiply each of these by 4x. Now again, because this is the first one we've done that we have, these multiple ones, I'm going to write it out again. We could still treat it the way we did on the last few, or when we look at each one, the first one, our x over x is going to simplify. The middle, 4 over 4, and the last one, x over x, because those are still going to cross out. We could have, in our first step, when we multiplied it by 4x, done that simplification there. We didn't have to write it all the way back out. But once we do that simplification, our 5 times 4 is 20, plus 7 times x is 7x, is equal to -9 times 4 is negative 36. Now we need to get x by itself, so we would minus 20. Telling us 7x is equal to negative 56. Seven and 7 is 49, so add 7, we get 56. So 7 times 8, so negative 8. So 2 negatives, if we divide a negative by a negative, it would be a positive. So here we're subtracting. So when we subtract a negative, or really we're subtracting from a negative, it makes it a bigger negative. So really what we could say we're doing is we're adding 2 negatives together. Questions on how we got negative 8? And we can plug this back in and actually get back to the fact that both sides are the same. Questions on any of this here? We're going to finish this tomorrow, because I think doing a few more of these will be helpful, and we'll go from there.